Welcome to my channel. If you like my videos, then kindly subscribe, like and watch. Thank you. Welcome back, and we will solve problem 5.7. The statement of problem is shown that draw the shear force and bending moment diagram for the beam and loading as shown in figure. And you have to determine the maximum absolute value of shear force and bending moment. So let's start with its solution. Now from this figure we can see that this is a cantilever beam having total length 0.3 plus 0.3 plus 0.3 plus 0.4. So total length is 1.3 meter and load at point C is 3 kilonewton acting downward at point D. It is 2 kilonewton downward at point E. It is 5 kilonewton upward, and at point B it is 2 kilonewton. So it is fixed at end point A. So in order to find the reaction forces at point A, I have already drawn this beam. So we have removed this support, and instead of this we will have a reaction force RA at point A, and there will be a reaction moment which is represented as MA. Clear? So we will find this reaction force and moment of reaction moment at point A. So let's start for reaction at A. For reaction at A, so we will first solve sum of all forces along y direction must be equal to 0 and upward force is positive. So you can see there is reaction force which is acting upward, so RA minus this force 3 kilonewton which is acting downward. So there is also another force at point D which is 2 kilonewton. There is upward force of 5 kilonewton, so that will be plus 5 kilonewton, and there is a downward force which is minus 2 kilonewton that is acting downward. Their sum must be equal to 0. So if we solve that, so R, the value of reaction force at this end is, this is 5, so this is 2 minus 4 and minus 7, which is minus 2, which is 2, minus 3 and minus 2, minus 5 kilonewton, and similarly this is plus 5 kilonewton, and this is minus 2 kilonewton. So RA will be equal to, basically this minus 3 and minus 2, this will be minus 5, and when it will move toward this portion, so it will be plus 5, and this 5 kilonewton when you will move to the right side, so it will be minus 5 kilonewton, and this minus 2 will be converted into plus 2, because when it will move to the right side it will be plus 2. So reaction force at point A comes out to be 2 kilonewton. So this was the reaction at point A. Now we will find the moment at point A. So sum of all moment at point A must be equal to 0, and counterclockwise moment is taken as positive. So we can see that at point A there is reaction moment which is counterclockwise direction, so MA will be positive. So MA, now RA is not producing movement because it is passing through point A. Point C is producing movement which is in clockwise direction, and that is equal to minus 3 into perpendicular distance is 0.3. Clear? This force is also producing a moment, so that is clockwise direction, so that is also minus 2. Now the perpendicular distance is 0.3 plus 0.3, which is 0.6. Again this force, now this force is producing, it is acting upward, so it is producing counterclockwise rotation, so that will be 5 into perpendicular distance is 0.9 because 0.3 plus 0.3 plus 0.3 from point A. So that is 0.9 minus this force which is producing clockwise rotation. So 2 into 1.3, which is the total length of beam, 0.3 meter. So their sum must be equal to 0. So when you solve that, so moment at point A comes out to be 0.2 kilonewton into meter, which means that this is counterclockwise movement, or the assumed direction is correct one. Clear? Now we have find the forces, reaction forces at point A and moment as well as at point A. We will move toward finding the bending moment equation and shear force equation, and then we will draw the bending moment and shear force diagram. So let's start from the section moving from A to C. So from A to C, from A to C. So if we section it, the beam will be shown over here. There is a reaction force which is RA, the moment which is given as counterclockwise because it is counterclockwise. So again the moment will be this MA. Clear? So also there is no force and you have cut the section over here, so there will be a shear force as well as reaction force, reaction moment at this point. Let this point is 0.1. Clear? So now by using the equilibrium equation, sum of all forces in long y direction will be equal to 0. So RA minus, let's say this is V, minus V is equal to 0. So V will be equal to RA, which is equal to 2 kilonewton. So this is the shear force equation for region A to C. Now we will find the moment at point 1, and that is positive. Their sum must be equal to 0. So now let this distance where we have cut this section, let this distance is x. Clear? So we have also here a bending moment of 0.2 which is counterclockwise. So this is MA. I will write its value 0.2 kilonewton into meter. Clear? And there is a force or reaction force RA which is producing, again that is also producing in clockwise direction. So that will be minus RA is 2 and this perpendicular distance is x plus this reaction moment, their sum must be equal to 0. So these moments come out to be 2x minus 0.2. So this is the bending moment equation for the region from A to C. Let this is equation 1, this is equation 2. Now we will move from section C to D. Now we will cut the beam over here. Clear? So from C to D. So I will draw the beam like that. That will, here it is RA. There is a counterclockwise movement at point A. This is point A. Clear? This is point C, where 3 kilonewton force is applied, and the distance from this to this point is 0.3, and we have cut the section beam over here. Let this distance is represented as x from point A. So if you cut the section beam over here, there will be a shear force as well as reaction moment. Let this is a 0.2. So this will be, there will be a shear force. Now we will apply the equilibrium equation again. Sum of all force along y direction must be equal to 0. So now you can see there is a reaction force which is acting upward, and this Ra is 2 kilonewton. So 2 minus 3 minus V is equal to 0. So V will become equal to minus 1. So minus 1 kilonewton. I did not write the unit, so at the end I am putting the unit. So this is the shear force equation for region from C to D. Now sum of all movement about point 2 is equal to 0, and counterclockwise movement is positive. Clear? So you can see there is a movement which is 0.2. So again this is plus because it is counterclockwise, and now this force Ra into x, and it is producing clockwise. So minus Ra into x, and this force is also producing a rotation in counterclockwise direction. So that will be plus 3. Now this distance is, this total is x, so from distance from this to this is x minus 0.3. So that will be x minus 0.3 plus there is a movement at point, reaction movement at point 2. Here sum must be equal to 0. So again if you solve that, this Ra is 2 kilonewton, so that will be 2x. This is 3 and this is x minus 3 plus m. So if you solve that, this will be 0.2 minus 2x plus 3x minus 0.9 plus m is equal to 0. So I will write over here. So this movement, the equation of movement for portion C to D comes out to be 0.7 minus x, because this will be minus 0.7 and this will be x. So this movement will be this. This is the, this is equation number 4. This is equation number 4. And this equation number 4 is the bending moment equation for region when we move from C to D. Now we will take the third section, and third section will be here from D to E. So from D to E, I will again draw the beam. So there will be a reaction force Ra, there will be a movement Ma at point A, this is point A, this will be, there is a force at point C which is 3 kilonewton. I will just write that 3, this is, let this is point D and the value is 2 kilonewton. This distance from this is 0.3, again from this point to this point, this distance is total 0.6, and let the distance from point A and where we want to section is represented as x. So again there will be a shear force and reaction moment at this point. Let this point is 3 point. I will write it in bracket. Okay, so you can see, you will apply the shear force equation. Sum of all forces along y direction is equal to 0. So you can see there is reaction force at A which is 2. There is a force at point C which is negative because it is downward, minus 3. At point 3 it is also minus 2, and shear force minus V is equal to 0. So V comes out to be minus 3 and the unit is kilonewton. So the shear force equation, or the value of shear force for the region from D to E is minus 3 kilonewton into meter. Let this is equation number 5. Now sum of all movement at point 3 is equal to 0, and counterclockwise is taken as positive. So you can see there is a reaction force which is producing a clockwise rotation. So RA into X, there is a reaction moment at point A, which is 0.2 kilonewton, and it is counterclockwise. So that will be plus 0.2, and this will be minus because it is producing clockwise rotation. Now this 3 force is also producing a counterclockwise rotation with respect to point 3. So that will be plus 3 into perpendicular distance will be from this point to this point. This distance is x minus 0.3. So x minus 0.3. Now this 2 force is also producing a counterclockwise movement. So that will be also plus 2 into perpendicular distance is now x minus 0.6, because this is the perpendicular distance and total is x. So this distance is x minus 0.6. Clear? Now again there is a moment at point this, and that is equal to 0. So this was 0.3, this was also point, this from this to this was also 0.3. Let me check it again. So that will be equal to minus 2 into x plus this reaction moment at point A, which is 0.2, 3 into perpendicular distance is x minus 0.3, which is equal to 3x minus 0.9 plus 2 into perpendicular distance is x minus 0.6. X minus 0.6. So that will be equal to plus 2x, and that will be minus 1.2 plus m is equal to 0. So m will be equal to this. When you move all the term to the right side, that will be 2x minus 0.2 minus 3x plus 0.9 minus 2x plus 1.2. So 2x will cancel each other. Here we will have minus 3x. So minus 3x, and this 0.9 plus this will be 2.1, and you will subtract it, that will be plus 1.9. So this is 3, actually this is 3x plus 1.9. So this is the bending moment equation for region when you move from D to E. So let this equation is equation number 6. Now we will move toward the final region, that is region from E to B. So let's do this also. So for region from E to B, so I will draw the beam again roughly. The beam will like this, reaction force RA, the moment at this point MA, this is C.3 kilonewton, this is let's say D.2 kilonewton, and there is a E point where 5 kilonewtons force is acting, and let this is the, from this point to this point, this distance is 0.3. From this point, from point A to point D, this distance is 0.6. From this point to point E, this distance is 0.9. And from this point to point A, let this distance is x. So there will be a shear force and reaction moment at this point. Clear? So this, let this point is point number 4 or section 4, because you have taken the section now over here. So we will solve sum of all forces along y direction must be equal to 0. So when you solve this, this RA is 2, which is acting upward, minus this force 3, minus this 2, plus 5, minus V is equal to 0. So V will become equal to this 2 will be cancelled, and this minus 3 will go over here, and 5 will be, so that will be minus 5 plus 3. Sorry, this, when this V will go toward right side, this will be V, so this will be plus 3, and this will be minus 3. So V will become equal to 2 kilonewton. So this is the shear force equation for region from E to B. Let this equation is equation number 7. Now last, sum of all moment at point 4 must be equal to 0, and counterclockwise, this is the counterclockwise, this is positive. Now you can see there are the forces, this RA. First one is the reaction moment, which is MA, and this M is 0.2. Now this RA, which is 2, so this is creating clockwise, so minus 2 into perpendicular distance is X. Now this 3 force is producing counterclockwise, so plus 3 into perpendicular distance is X minus 0.3. Again, this force is also producing counterclockwise, so plus 2 into X minus 0.6. Now this force upward, it is producing a clockwise rotation, so that will be minus 5 into X minus 0.9. Clear? And there is a reaction force M, which is again counterclockwise, so their sum must be equal to 0. If you solve this, so this M comes out to be 2x minus 2.4. So this is the bending moment equation for the region from E to B, and let this equation is equation number 8. Now we have solved this question, we will move toward plotting these all the value of bending moments and shear force on the graph. So on the left side you can see I have already drawn, this portion is for shear force diagram and this portion is for bending moment diagram. And again I have taken, you can take it depend upon your scale. So I have assumed from this point to this point it is 0.5 kilonewton. From this point to this point it is 1 kilonewton. Similarly 2 and 3. So you can take it depend upon your scale. So let's start with from point A to C. So if you see from A to C the equation of shear force, that is 2 kilonewton. So 2 kilonewton is from this point. So from A to C there is a 2 kilonewton. There is no change in the shear force. Now from C to D, now at point C you can see that the shear force is minus 1. So from this point it will come to this minus 0.1, which is I have already shown as you can see over here the points. Now from C to D this value is minus 1 and constant. So from C to D this value is minus 1. Clear? Now at point D you can check from D, this is minus 3. So it will come toward minus 3. So this point is minus 3. So that is minus 3. This point is minus 3 kilonewton. This is minus 1. Again from D to E, from D to E its constant value, that is minus 3. So from point D to E, so this point is actually E point. So this is minus 3. Now from E to B, you can see from E the value is also 2 kilonewton. So again it will go toward this point. So when you join this, so it will go to this point is 2 kilonewton. Now from point E to B it is constant 2 kilonewton. So it will be same like this. So this is basically your shear force diagram. This region show you the shear force diagram for the above beam. You can also pick the value of shear force. At this point it is minus 3 kilonewton, at this point it is minus 1 kilonewton, at this point it is 2 kilonewton. So this was the shear force over the entire length, distribution of shear force over the entire length. Now we will move toward the bending moment equation. So let's start from A to C. So from A to C you can see that this is the equation of bending moment. So if x is equal to 0, so at x is equal to 0, m will be equal to minus 0.2. So again here you can also take the you have to take the appropriate scale. So I have assumed that this is 0.1, this is 0.2, this is 0.3, and similarly the same over below with negative sign. So let x is equal to 0, so this m will be equal to minus 0.2, so this point will be this one. Clear? Now at from A to C the distance is 0.3. So if you put 0.3 over here, x is 0.3, which will be equal to 2 into 0.3, it will be 0.6, and when you will subtract 0.6, when you will subtract 0.2 from 0.6, it will be 0.4. So let this is 0.3, this will be 0.4 kilonewton into meter. So this point is 0.4. Also, I have also told you that this is a 0 degree equation or constant number. So bending moment equation will be the first degree equation, and this is also shown in this equation. So you can easily join them over here. Also for at any value of x is this length. Clear? So this is 0.3, from this point to this point 3, this point 3, this total from this point to this point is 0.9, and from this to this point it is 1.3. So at any value of x you can calculate the value of moment and you can plot. So by the end you will get this same line. We will also check at the end. Now from C to D we will have the bending moment equation, which is 0.7 minus x. Now at x is at x is equal to 0.6. So if you put at value of x at 0.6, because 0.3 and 0.3, it will be 0.1. So this point is 0.1. Again you can join them like a straight line, because the shear force is a 0 degree line having no slope, constant line. Now from D to E, equation from D to E, the bending moment equation is minus 3x plus 1.9. So if you want to find the bending moment equation, so x will be 0.9. So when you put 0.9 and you solve it, so it will give you minus 0.8. Clear? So minus 0.8 comes out to be here. So again, if you have to join them over here like this. Clear? Now from E to B, the shear force bending moment equation is this. So when x is equal to 1.3, so that will be 2.6. So it will be somewhere above, or it will above the xy line. So kindly check this value whether it comes out to be 2.4 or 2.6. If this is 2.4, so definitely this point will lie over here. But if it is 2.6, so this point will lie over here. I have calculated as per my calculation, it comes out to be 2.4. So let's do it like this. So if you put x is equal to 1.3, so that will be 2.6 and it will give you 0.2. So 0.2 is this. So this value will be over here if the calculation is like that. So if this come out to be 0, you can join it like that. But as per this calculation, we will draw it. So the line will be, let me check, 0.1, 0.2, 1, to this point. So you can join them like this. So you can see this will be the bending moment equation, bending moment diagram for the above beam with loading shown as. Now we have solved the first part, which is draw the shear force and bending moment diagram. Now we will check the maximum absolute value of shear force and bending moment. So you can see there is a shear force 2 kilonewton, 2 kilonewton, minus 1, minus 3. So minus 3 is the maximum shear absolute value. So maximum shear force will be having absolute value minus 3 kilonewton. So that will be maximum shear stress is 3 kilonewton. That is the A. Now for B, maximum value of bending moment. So you can see this point is 0.2, this is 0.4, this is minus 0.8. Now minus means clockwise direction. So we will take 0.8 kilonewton into meter, which is the maximum bending value moment. So that is minus 0.8 kilonewton into meter. Sorry, kilonewton into meter. So the absolute value of bending moment is 0.8 kilonewton into meter. I hope you have enjoyed the video. Again, I will also show you that you can take, for example, if you want to see that at this point, at any length, for example, this is 0.3. So if you divide it into 3 and put the value of, for example, x is equal to 0.2, and when you put it over here 0.2, so you will, on corresponding y-axis, you will check that you will have the same bending moment values. You can check it also by yourself. Again, thank you so much for giving me the time. And if you like my video, kindly subscribe, like and share. Also, don't forget to press the bell icon for upcoming video.